Hello, today is our last lesson of Unit A. We are going to do word problems with the three sections, lesson 1.5, 1.6, and 1.7. What you're going to notice is as we go throughout the semester, we're going to learn some material, and then there's always going to be a word problem lesson that's going to be the application of what we had learned. So basically here I just have a variety of problems. I'm just going to talk about how to set them up. I have, I think, one for you to try on your own, and we'll talk more about this tomorrow in class. Okay, so this one's pretty simple. It says the formula for surface area of a sphere is A equals 4 pi r squared, where r is the length of the radius. Find the surface area of a sphere with a radius of 10. So basically, this goes into r. So we're going to do 4 pi 10 squared. So what you can do on your calculator is you can actually do 4 times pi, which is 3.14, times 10 times 10. When you do that, you get 1,256. Surface area is units squared, so feet squared. So this one's pretty straightforward, not too bad. Okay, we will see perimeter problems throughout this semester. So what you absolutely need to know is the formula for perimeter. I'm not giving this to you, you should know it. Perimeter is 2 times the length plus 2 times the width. Okay, now let's go ahead and read the problem. The width of a rectangle is 4 meters shorter than half the length. So the length we don't know, we'll call it L. The width is 4 meters shorter than half the length. So we want to do half the length first and then subtract 4. So what we're going to end up doing is plugging this in for L and this in for W. The perimeter is 19, so this goes in for P. So we have 19 equals 2 times L plus 2 times 1/2 L minus 4. Now here it's very important to distribute. A lot of students forget to distribute. So we get 19 equals 2L. 2 times 1/2 is 1, so L. 2 times -4 is -8. So what I'm going to do here is combine my like terms and then add 8 to both sides. So when I do that, I get 27 equals 3L. Divide both sides by 3, and our L is going to be 9. Now let's read the question. It says find the length and width. So my length is going to be 9 meters. My width is going to be, take this, put it in. Half of 9 is 4.5. 4.5 minus 4 is 0.5. So 0.5 meters or a half meter. Okay? So not so bad. We're going to see perimeter definitely in the next couple of units. So make sure you understand that perimeter is 2L times 2W. No. Okay. Next problem, number 3. A train travels between Boston and Washington, a distance of 457 miles. The trip takes 6.5 hours. What's the average speed? You should know this from science. Distance equals rate times time, so you should know this formula. The distance is 457. We don't know the rate, but we know the time is 6.5. So I'm going to divide both sides by 6.5. Now, what did you just divide? You divided 457 miles by 6.5 hours. So when we get our R, we are going to get 70.3 miles per hour. Okay, next problem. This one's a little tricky, but we're going to see several of these, and they're basically all going to be the same. A parameter is a parachute propelled by a fan-like motor. The table shows the height h of a paramotorist T minutes after beginning a descent. Find the height of the paramotorist after 7 minutes. I want you to think of this as y equals mx plus b. Okay? Our time is going to be our x. Our height is going to be our y. So our starting point is always where x is 0, right? It's where it crosses the y-axis. So this is our b. So I'm going to go ahead and plug 2,000 in for b. Okay, our m is our slope. So what's happening to our rise? What's happening to our rise? Hopefully you notice it's going down 250 feet. That's our rise. So we're going to have negative 250x. What's our run? Our run is going up 1, so negative 250 over 1. This equals y. Okay, now what is our x and y? Our y is height, so I'm going to change our y to h. And our x is t. It says find the height of the paramotorist after 7 minutes. So we can go ahead and plug 7 in for our t. So all you're doing is negative 250 times 7 plus 2,000. When you do that, you get a height of 250 feet. Now, can you just say, oh, it keeps going down by 250. I'm already at 4 minutes. I'm going to subtract 250 for 5 minutes, subtract 250 for 6 minutes, and subtract 250 for 7 minutes. Yes, you can, and you don't have to do any of the equation, and you will get the answer. However, I know that upcoming, there is a question where it doesn't ask for the height after a certain amount of minutes. It actually asks for the equation. And if it did, your equation would be h equals negative 250t plus 2,000. That's why I went through this process. Okay, next problem. Draw a picture when you need to. You are hanging 4 championship banners on a wall in your school's gym. So let's draw a gym. So we have a wall. This is our gym. We're hanging 4 banners. 1, 2, 3, 4. The banners are 8 feet wide. So we have all these 8s. The wall is 62 feet long, so the whole thing is 62 feet. There should be an equal amount of space between the ends of the wall and the banners, that would be here, and between each pair of banners. How far apart should the banners be placed? So you're actually solving for x. So you're going to add all of this up and set it equal to 62. That's 5 x's, and 32 is going to equal 62. Once you go ahead and do the algebra and solve this, you get 5x equals 30. X is 6. So the distance that these banners should be placed between everything is 6 feet. Okay, let's go ahead and do the last problem. Now, I think this problem is a little bit easier when we're doing a system of equations, but we're going to try to think of it in terms of one variable because right now we're doing linear equations. So a car used 16 gallons of gasoline and traveled a total distance of 460 miles. The car's fuel efficiency is 30 miles per gallon on the highway and 25 miles per gallon in the city. How many gallons of gasoline were used on the highway? Okay, we know we're traveling a total distance of 460 miles. We know we're going to have some highway miles and some city miles. Okay, we have both. Now the fuel efficiency is 30 miles per gallon on the highway. So I'm going to do 30 miles per gallon for the highway plus 25 miles per gallon for the city. Now instead of using a different variable, we're talking about this in terms of gallons. We know we use 16. So we know if a certain amount of those gallons are used up for highway, the leftovers is going to be for city. So 16 minus city, or excuse me, minus G. Okay, so this is gallons of the highway, gallons of the city. Go ahead, distribute here. 30G plus 400 minus 25G equals 460. Add up your like terms, so we get 5G plus 400 equals 460. Subtract 400 from both sides. So we get 5G equals 60. Divide both sides by 5. And G equals 12. Now, we have to answer the question. We found G. It says how many gallons of gasoline were used on the highway. The highway did represent G because it was the 30 miles. So we are done. It's 12 gallons. Now, if I would have asked for city, we would have had to do 16 minus 12. We would have 4. Okay, I would like you to pause the video. Try this. You try on your own. It's a different problem than we've done, so draw a picture to help you out. And then if you have any questions, comments, or concerns, go ahead, write it on the bottom of the paper, and I'll see you tomorrow in class.